Welcome to chapter 11. Continue on with our uh, videos. This is chapter 11 within subject experimental design. This is kind of continuation of chapter 10. So we've been talking about the experimental design at this point. Chapter 11 focus on within subject study. Chapter 10 we already talked about the between subject. What is the between subject? You have 2-3 groups or more, and you assign those people, number of people into those groups, and then each group will test different things. Okay, so chapter 11 is a little bit different. Okay. Without further ado, we'll go in to talk about chapter 11. So chapter 11. So within subject, instead of between subject as it sounds, within subject is the same participant doing things within that same group. Okay, within that same group. So you're gonna randomly assign, and you randomly selecting these participants. You're randomly selecting these participants, but you're not randomly assign them because every single one of them gonna go through exactly the same thing. Okay, instead of have a control group, people who in the control group only do control experiment. Everyone is going through everything. So let's say you have each participant, they will be the control. They're also gonna treat them, have the experiment done on them as well. So they'll do both the control and the experiment all in one. Okay. So very common, we actually use this, and the reason we use this is you don't need a lot of people. You don't need a whole number of people. You only need a few. Unlike the between subject, you may need at least 30, 40, or 60 people to conduct your study. Let's say you want to have at least 10 or 20 people in each group, in each category. One group will be control group, the other one is treatment group. At least you might want at least 10, 20, or 30 people in each group to have a significant stat for your calculation wise, to show truly significant. You need that number of people. But with this, you could actually have a small number of people. You could have only 5, 10 people, even 6 people to conduct your study. You don't need that large amount of people to conduct your studies. The downfall of this is you're going to do it over time, since you're actually doing control and experiment with the participant. You actually need to give some time for them to rest or go back to that baseline before you give the next treatment or next protocol. Okay. Again, you don't need to use the random assignment because everyone gonna experiencing the same thing, because they all gonna go through the control, they all gonna go through the treatment. So you don't really need to randomly assign them, but hopefully you randomly select them. You randomly select the participant. You're not picking your friends, you're not picking your colleagues or your coworker, your family members. So hopefully you randomly select those participants, but not assign them to the group. Okay. Something to keep in mind for these studies is you're gonna have the testing effect test, the maturation. The longer you're doing it, you're gonna have people could be more mature. Testing effects, if you keep testing them with the same test over and over again, they may improve their score because they kind of get used to the test. Regression toward the mean, hopefully you remember this from chapter 6, is that they score really well. They did really well at first, and then the more you test them, they kind of go back down to the average, what the average is. And the key terms you might want to know, especially with this study, is called attrition. If you do it long study, people gonna drop out like flies with your study. They feel fatigued. They don't want to continue your study anymore, so they drop out pretty quickly. Something to keep in mind. The biggest thing in this chapter to remember is these two. One is called the order effects, and the other one is carryover effects. Order effects is if you have more than one treatment, you want to make sure that which order is actually going could be very important of how the number your data could actually show up. So you want to make sure that the order doesn't only matter. So each person you have, each participant, you might want to mix up the order. You don't want, let's we call it A, B, C, or D. Let's say if you have 3 type of treatment you want to try and then one control group. You don't want to start with A, B, C or A, B, C, D every single group. You want to kind of mix them up. Okay, mix them up with each one. Because one treatment can actually carry over. That's what carryover effects is. That one treatment can actually carry from one group to the next, to the next, and to the next group. So you want to make sure that that doesn't happen. So in order for us to counter these effects, we use something called control order and control timing to actually counter those effects. Control order, which is counterbalancing. Let me show you what counterbalancing looks like. An example is here. Counterbalancing, if you have 2 treatment groups, you don't want everyone to start with a treatment A and then goes to treatment B. You might want to mix them up. You want to mix them up in each one. So some might start with A first, and some might start with B first, and then goes to A. So and vice versa. To see how the effects works. Okay, that's called counterbalancing. There's a couple of counterbalancing. One is the complete one, which is number of groups that you have. If you have 3 groups, let's say you have 3 groups, you have the 1 control group and 2 treatment groups, so that you have total of 3 groups. What you want to do is you want to calculate all the possible outcome from that 3 group. The way we calculate this is called using what we call factorials. So if it's 3, then you're gonna 3 multiplied by 2, and multiplied by 1. So you're gonna go down from 3 multiplied by 2, which is 6 multiplied by 1, which is also 6. So therefore, in order to counter this effects completely with 3 groups, you're gonna have 6 different combinations. So you need at least 6 participants to participate in your study, and assign each one of them all different sequences. So first one might be ABC, second one would be ACB, third one would be BCA, next one would be BAC, so on and so forth. So you actually assign them all with possible orders to make sure that there is no order carryover effects. Okay, 3 group is pretty doable. Only 6 participants you have to worry about. But if it's more than 3 groups, like 4, if you do factorial 4, which is 4 times 3, which is 12, times 2, which is 24, times 1, which is also 24. So if you have 4 groups, 4 treatment groups, you actually need to have 24 participants to cover all of those groups. And that could be hard sometimes to find 24 people and doing that long of a study. So a lot of time what we do is we use something called Latin square. Latin square is to actually help finalize. If you look and see here, it's 4. You have all the 4 possible combinations here. But we pick what is the most representative of the 4 that we should focus on. And we could only do, all we have to do is these 4 sets instead of doing the 24. So we only need 4 participants to participate in this study instead of 24 people. Make the research a lot easier to conduct, not make it long lasting forever. So this make it nice, brief way to conduct the studies. Okay. So make sure you actually give time between the treatments. So when you conduct your study, give them some time off to make sure that there's nothing carry over. Okay, so you need to have resting period. Also, key is to disclose any potential risk as well for the participant to make sure they're aware of the risk that they are taking. there could be, between subject, you could have a between groups variabilities, meaning that each group could be different because of different makeup, different people. Individual factors could actually play a big role into between group studies, but within subject study, there's no differences because one person taking different treatment themselves. But what you're gonna have is you're gonna have the individual differences in terms of people who are participating in the test. So you might see that instead. Okay. Let's see. Again, the test that we use for this is the t-test, but if you have more than one type of groups, what you want to do, so the t-test, if you only have like two groups to compare, 2 to 3 groups to compare, usually 2 group would be ideal with t-test. But anything more than 2, we would recommend using the one-way ANOVA to actually analyze it. And again, from last chapter, if you were to use one-way ANOVA, hopefully you use post hoc afterward as well to confirm your test. Okay, the more tests you have, the more the complexity of design you have to worry about, especially the four or more groups. You want to make sure you could use this Solomon 4-group design to test things out, to make sure that you cover all the bases and you could compare between them. For instance, with the Solomon 4-group, the first person would do pre-test, treatment, and post-test. The group B would only do pre-test and post-test. There's no treatment. Group C would do the treatment and the post-test, but no pre-test. Group D, there's no treatment at all, but you could only post-test. So we could compare the one that did that without treatment. Compare the one without treatment and see, looking at the post-test, to see the differences in between those. We could also compare the treatment group to compare the post-test to see how the differences between those. And we could also compare the pre-test group, these two, and if there's a difference between treatment without treatment, to see whether there's a differences in there as well. Okay, so this is how they break it up, kind of what I just explained to you a little bit there, how they actually could be break up into, this is called the complexity of design. Break up and compare. This is mainly based on this statistical analysis to make sure that we cover all our bases. Okay, again, there has to be the random assignment. Okay, but there's for participant, for between subject, there's no random assignment. For the within subjects, there's hopefully random selection still. Okay, and the rest of these kind of go through the differences between the between and within subject study. Well, thank you for watching, and I'll see you on the next PowerPoint.